Okay, let's settle down. We have the last of our 4 presentations. The EXO presentation will come up in a minute. But before we start, I would like to welcome and introduce... I would like to welcome and introduce Michael O'Brien. Mike O'Brien, otherwise known as to everybody as Obi. Obi, please stand up. Obi is the... thank you, Obi. Mike, Obi is the Associate Administrator at NASA for International Relations and puts on more miles, I think, per week than most of us put on per decade. So a man that is all over the world at any one time. So let's get right into EXO. I'd like to acknowledge the very generous support and sponsorship of the EXO mission by friends at Lockheed Martin, as well as at NASA. So thank you very much for that sponsorship. And we will get right in, and I will like to introduce Eric Choi, who all of you know, the chair of the EXO project. So over to Eric.
Thank you, David. Good afternoon, everyone. Why are we interested in exoplanets? What is the fascination with the notion of worlds beyond our own solar system? Well, there are a lot of reasons, but one that comes top of mind, I think, is that it speaks to our intrinsic place, the place of humanity in the wider universe. Once upon a time, people thought the Earth was flat. Once upon a time, people thought that the Earth was at the center of the universe. And then came the heliocentric model, the sun-centered model, advocated by Nicholas Copernicus. And more recently, I would argue that a new Copernican revolution is underway. It's only been about 20 years since the first exoplanets were discovered, and since that time, quite literally, it's a field that has exploded by leaps and bounds. I think right now there's something like 1,800 confirmed exoplanets, and about 4,000 more candidates are awaiting confirmation. So this is really a very exciting and opportune time to be in this field, and I think a very appropriate time to bring to bear the international, intercultural, and interdisciplinary standpoint of ISU to the field of exoplanets. Now, over the last 9 weeks, Tom Wilson, the teaching associate, and myself have had the great pleasure of joining 28 remarkable people from a dozen countries on an amazing journey of exploration. And it's a journey that is going to culminate here this afternoon. To our generous sponsors, NASA and Lockheed Martin, thank you. And as a very small expression of our appreciation and gratitude, we would like to share with you now a vision of the future, a vision from ISU SSP 2020, so that you yourself can see firsthand the dramatic impact that your generosity has made. Thank you very much.
Hello, good evening, ladies and gentlemen, distinguished professionals. I'd like to welcome you to the 2020 expert panel on exoplanets and the Exoplanet Exploration Organization. Give me great pleasure to introduce you to Caitlin Kersey, the director of the president of the organization and former head of the UK Space Agency.
everybody. As introduced, my name's Caitlin, and I'm the director of the Exoplanet Exploration Organization. So, good evening. This is SSP 2020 in the future. So, I'd first like to start off by saying that everybody here on the stage and in our support team are all graduates of SSP14. And so we really understand how tired you all are, how much work you have going on, and we just wanted to say thank you very much for being here today. So what we're going to start off with was, you've had a brief introduction as to why exoplanets. So, the slide, yep. So we started off thinking about our universe as a flat Earth. We thought the Earth was flat, and that the Earth was also at the centre of the universe. Then came the Copernican revolution, where we realised that the sun was actually at the centre of our solar system. This is something which you could call a disruptive discovery. It completely changed the way we thought about our place in the universe. In the 1960s, things changed again, with man landing on the moon, and completely inspired the next generation. Finally, if any of you have seen Hubble's ultra-deep field image of the darkest patch of sky filled with hundreds of billions of galaxies, and each one of those galaxies containing 100 billion stars, it does put things slightly into perspective as to how large our universe is. So to define an exoplanet is a planet orbiting a star, so planets outside our solar system. So going back to that image, hundreds of billions of trillions of stars, there must be such potential out there for other planets. So what I'd like to do is I'd like to introduce our team for today. So after me will be Amir Naver, our head scientist, who will tell you about some of the research that we've been doing. Next we have Daniel Brack, our head of project, who will be telling you about our unique mission. Then we have Saho Fukushima, our vice president and head of finance, who will be explaining some more about the organization. And Alana Bartolini, our head of PR, who will be telling you all about our outreach efforts and how you can get involved. So a little bit of history. So in 2014, we were the Exoplanet Team Project group, and our mission was to come up with a set of recommendations to progress exoplanet research. So what we did is we identified two major gaps. The first was that there was no organization responsible for bringing together people and groups from around the world to collaborate on exoplanet research. The second gap was that the majority of missions at the time, which Amir will talk about a bit later, all these missions were looking at detecting exoplanets, but there weren't any there for characterizing them, and so we designed the unique mission. So, next slide, please. So, we formed the EXO organization. So, EXO stands for Exoplanet Exploration Organization. And our vision was to produce an organizational framework for 3I, intercultural, international, and interdisciplinary collaboration on exoplanetary research, education, and outreach. As part of this, we wanted to identify and develop a mission to unite exoplanetary research groups around the world. And I'm very pleased to say this has been a success. So, for our next slide. So this is the state as it is in 2020. You can see here all these dots. The blue correspond to observatories, which are searching for exoplanets, and the orange are universities who are conducting exoplanet research. So what we've managed to do is we've managed to bring all these people together. So we have national agencies, educators, amateur astronomers, and academic institutions. And going on, scrolling down, we are bringing, or what we've done is we've brought all of these groups together to be part of our organization, and we are helping them collaborate on outreach, research, and education. And as I say, it's been very successful. So, as a brief bit of history, we have the timeline for our organization on the next slide. So we were very aware when we were starting off that it can be quite hard to gain a reputation as an organization. So we focused on outreach, education, and getting some smaller universities and groups involved. And they led into our first founding conference, which was a very big success. We had people from all over the world come together to discuss and share their passion for exoplanetary research. From there, we were able to develop further and build the requirements for our mission designs for the unique mission, which you'll hear about in a second. And then eventually, we've managed to become big enough, and our first unique mission was actually launched earlier this year. So it's all going very well, and you'll hear about everything much more in detail now. So what I'm going to do is I'm going to hand over to Amir, who's going to tell you all about the science behind exoplanets and their characterization. Thank you.
Thank you, Kate, for your kind introduction. So before we go into EXO and what it actually is doing, we want to understand a bit more about exoplanets, what they are, and how we can find them, the missions we are currently undergoing, and maybe get you into this world of exoplanets a bit more. So an exoplanet is basically any planet that is not orbiting our own sun. But this is quite a large definition, and we have very different exoplanets. So a couple of examples is there are exoplanets we have already found, 20 times the mass of Jupiter. And so we have exoplanets that their surface temperature is actually hotter than the surface of our own sun. And also in the terms of orbital periods or the distance from the suns themselves, we have exoplanets orbiting in 163,000 Earth years. And on the other hand, exoplanets orbiting for only a few hours. So we see these worlds can be very, very different from our own world, and this is only from the worlds that we know today. So let's see a bit about how the number of exoplanets and what we have found has been progressing over the years. We can see here two graphs, and on the bottom graph we see that the growth of the number of exoplanets we know of is growing exponentially. From the first exoplanets found in 1992, we have been growing up to 15,000 exoplanets today in 2020. This means that we are growing exponentially, and we are finding more and more interesting ways to find these planets and at an ever-growing number. But the top graph is maybe of more interest, because if we talked before about the diversity of these exoplanets, we can see that there are quite a lot of exoplanets that are actually similar to our own planet. And we see specifically in the second column from the left, Earth-sized planets. And the orange place there is labeled habitable worlds, meaning worlds with a temperature similar to our own planet, where liquid water can exist. Now, we do not yet know a lot about these planets, but this means that we are, in some sense, not very special in our universe. And we have a lot of planets very similar to our own, and we want to pursue this knowledge. So how do we find these exoplanets? What are our main ways to detect them? So as we can see, there are quite a couple of methods, and I will elaborate on this in a second. But I want to stress the point that quite a lot of these foundings we have are actually candidates and not yet exoplanets. We have quite a lot of false positives in this field. We can suspect we found an exoplanet, but actually be seeing a sunspot instead. And so the candidates is something that we want to confirm and make sure that we actually are getting the right number of planets right, and not just seeing false positives with our detection methods. And we will talk about this and also in a couple of slides. So the most maybe common method we are using is called the transit method. And what happens here is that a planet orbiting its own sun, when it passes through the sun, it blocks some of the sunlight that we can see away from us. And so, as you can see in the right figure over there, the sunlight we see has a small dip when the transit occurs. Now, this we can only sense when the planet orbiting its sun is in the same plane as our own observation instrument. So we cannot see all the planets this way, but quite a lot of the spacecraft are using this method, and it is the most common one. So other methods we are using are two complementary methods called astrometry and radial velocity. Radial velocity and astrometry both use the fact that the planet and the sun are both orbiting a common center of mass that is not in the center of the sun. So the sun itself is actually moving. If it is in our same plane of view, we will see some sort of Doppler shift in the spectrum. If it is moving towards us, we will see the light shifting towards the red spectrum, and if it is moving away from us, towards the blue spectrum. And so we can actually identify these small movements. If it is in the perpendicular plane, we will see the sun moving up and down, which is called astrometry. And our measuring techniques for these systems are becoming better and better, so we can know more about these planets, their masses, as time progresses. Other methods that apply for less of what we know are, first of all, direct imaging, trying to block the sun, the main light of the sun, trying to actually detect the light from the planet itself, which is quite a lot of orders of magnitudes smaller than the sun, but we can still manage to detect it. And again, this is becoming more and more common in these years. And finally, we have quite a lot of other different methods. The first exoplanets actually found were not in any of the above stated, but using a method called timing, which means that we are utilizing the fact that pulsars have a very stable pulse frequency, and we are using that to find how exoplanets are actually influencing it. And many more, micro-lensing and a couple of more methods. So we are quite diverse in this field. Each of these methods can find other planets, have different pros and cons, and we are using them all in a complementary way to find more and more exoplanets as time goes on. So maybe let's talk a bit about the missions that we are using to find these exoplanets. What we have here is a graph that is visually stating where the missions are actually located. So we see there are missions in the low Earth orbit, in high Earth orbit, in the GEO, in the Lagrange 2-point. And of special importance, I would like to state two major missions that are going underway. The first one is the Kepler mission, which was maybe the first big milestone for detecting exoplanets. Detecting already in the beginning of the 2010 decade, it detected over 1,000 exoplanets and found thousands of more candidates. So this was maybe the first mission that gave a huge boost to this field using the transit method. And now, in 2018, just launched, was the James Webb Space Telescope, which has a 6.6 meter aperture telescope and can actually find a lot more about these planets, about their spectrum, and maybe attempt even direct imaging. But this spacecraft cost quite a lot of money, approximately $8 billion. So we are talking about very large missions that are also very costly. In the future, we expect WFIRST, Plateau, Spica all to be launched using both the transit methods and spectroscopy to try and help advance this field farther away. So last, I would like to talk about where are we now, what are our current gaps in the scientific knowledge, and where we want to advance. So as you can see, and as already shown, the number of confirmed exoplanets is growing exponentially. But what is also happening is the number of candidates is also growing through these false positives that our methods give us. And this is something that we want to try and narrow down. We see that we want to take full advantage of the spacecraft that are already out there. And if we invest billions of dollars in these spacecraft, we want to try and narrow down as much as possible the exoplanet candidates and make them confirmed. And we can actually do this thing using amateur astronomers, using ground-based instruments, using very small ground-based telescopes for confirming those exoplanets. And so some of what EXO is trying to do is actually appeal to those people. But maybe of even more concern is that we have the numbers. We have quite a lot of confirmed exoplanets, but we don't yet know quite a lot about them. If we find water in their atmospheres, if we find methane, if we found ozone in their atmospheres, this could very well be the biosignatures that can imply that life similar to life on Earth is actually happening in these planets. We saw quite a lot of planets in the habitable zone, just like the Earth. So if we find these biosignatures in some of their atmospheres, this could be an indicator that we are actually we can actually hope to find some sort of life, maybe even intelligent life, similar to our own. And this is something that has both scientific interest, but we also believe has interest for all of mankind. And so in EXO, what we have been trying to do is to develop a mission both for public outreach, to get people excited about these exact things, and also develop the unique mission, which you will hear about, trying to also characterize these atmospheres of the planets. So we call on you to get involved and to get interested in these questions, and we really do think this is the next Copernican revolution. Thank you for your attention, and I would like to call our head of project for Unique, Daniel.
Thanks a lot, Emil. My name is Daniel. I'm the head of projects for EXO, and I want to present Unique. Unique stands for the United Quest for Exoplanets. It is a CubeSat or microsatellite mission, 6 satellites from different partners, if Rick will show them to us, from around the world. It's led by EXO, together with our bigger partners, which are giving financial, technical support and knowledge. It is also a mission that is very special because each partner, each contributor to this mission is actually has designed, built, and is operating their own satellite by themselves according to our specifications. And they are giving us all the data that we want, but still controlling their own satellites. If we go to the next slide, we can see the concept that Unique, and for a very big extent EXO as well, is operating. We're getting data, we're getting exoplanets from different sources. Here you see TESS that is giving us different planets or different candidates detected. We have other missions which are verifying these exoplanets, both in space and on the ground. And then we take this data and we give it to the Unique satellites, and we look to see what they can give us about that data. Now, our Unique satellites are in a low Earth sun-synchronous orbit. Because of their instrument, they have to always look away from the sun. So they have a very specific portion of the sky they can look at different times. So what we do is we look at our database, we look at what missions or what transits we're experiencing at that specific time in that specific area. We rate them, we find what's the most interesting ones, and we have either all of our satellites or different satellites look at different transits and get as much information as we can about those transits. Now, the nice thing that we can do with this in this way of operating is we actually give the freedom to our members to use their own satellites for their own missions when the schedule allows. So when the schedule lets us, we have them operate their own satellites, looking at whatever event or whatever observation they want to do. And that would actually give them the opportunity to give added value to their own satellites that they built and designed. If we look at the next slide, like I said, and like Emil said, the Unique satellites use the method of transit in order of looking at exoplanets. Here we can see a planet transiting its star. The light from this planet is actually traveling through the light from this star is traveling through that planet's atmosphere and coming to our sensors, and we then analyze the light that we've seen. And this is the portion in the lecture where I know you had a long day here at SSP. In our SSP, one thing that we used to do a lot is waves. So we're going to have an example of the method that Unique works in, and we're going to have a wave. I'm going to have a few volunteers from that row. I know your names already, so done and done. Stand up. No, you stay standing. That's the thing. So whoever is directly behind done and done, I'm sorry, you're not participating in the wave. We'll explain in a second, but everyone else, get ready. I'm going to 3, 2, 1 you, and starting in the first row, we're going to have a wave. So 3, 2, 1. Okay, that was a good first try. We took a while in our SSP to get it going. I understand 2020 doesn't do it. It's fine. But okay. So the method that I was trying to show here is something we call absorption spectroscopy. what we do is we look at the light that goes through any material, in this case, the exoplanet's atmosphere. We look what lines are missing, and we can actually deduct from that different materials in the atmosphere. Our specific sensor works in the near-infrared, so it's looking for these molecules that you see here. We're talking about oxygen, we're talking about methane, we're talking about water. These are molecules that we know are related with life. And so this is the direction that UNIQ wants to look at, but that's not the only thing. We also look at other planets. And if we actually go to the next slide, we can see some of the specs of UNIQ. Okay, these are basic specs because each partner, like I said, have their own design, have their own satellite. We can see we're talking about a 12U CubeSat, so it's a microsatellite, not very big, 12 to 15 kilos. It has like I said, near-infrared sensor between 0.9 and 2.5 micrometers. It is in a low Earth sun-synchronous orbit, and like I said before, always looking away from the sun, so always looking in the opposite direction, and that's very important so our sensor doesn't heat up, and so we are always able to look at transits, because if our sensor heats up, we have to wait until it cools down again in order of doing our sensing. The lifetime for these satellites is designed for 3.5 years. We're hoping for a much longer lifetime. And we're hoping to have the next mission of UNIQ's launching very soon. If we look at the next... so here you can see some of the objects that UNIQ have already sensed. We're talking about Kepler 186f. It's in Earth size in a habitable zone area. We found water in its atmosphere. And if we look at Tau Bootes b, this is again an Earth size and habitable zone. We're also planning to look at that. I will now have a short video from one of our scientists working on the UNIQ science. Let's see what she has to say.
Hello, my name is Christina. I'm a postdoctorate from Malta. By joining EXO, my astrobiology research team has had the ability to process data from the UNIQ satellites. We get to characterize the atmospheres of exoplanets and publish our conclusions about these exotic new worlds before they get uploaded to the Exoplanet database. With the Exoplanet database, everyone is able to access vast amounts of exoplanet data out there. The visual tools help everybody understand a big picture, and each exo page tells us even more about a specific exoplanet. For example, if you look at this piece of the sky, you can find at P1b, it is a gas giant that has water molecules in its atmosphere. This water was detected by the UNIQ satellite mission. We can also use our data links to see the planet's page and the raw data readings. I would just like to add that EXO has given me and my colleagues a great opportunity to collaborate in our study of exoplanets. Bye for now. Ciao.
She'll explain a bit more about EXO and how it works.
Hi, can you hear me? Yes. My name is Saho, and hello to ISU 2020. It's nice to be back here and able to represent our organization, EXO. I will start with the structure of our organization. And our organization has grown so big over the years, so please allow me to refer my notes sometime for the accurate information. So we have Board of Directors as our governing body. We also have 5 committees, as shown in the diagram, as exoplanets. Please note that the distance from the star doesn't indicate the importance. If you put the mouse over, you can see they have the equal importance. Now, going back to the pretty picture, I will start with outside to inside. So let's start with the big brown planet. Public platform. The public platform have 3 sub-branches. They are Exo Society, Exoplanets Data System, and Commercial Mission Partner. Exo Society makes exoplanetary research very accessible and exciting. Their activities include helping schools and educators. It also helps institutions to design and build own missions. Exoplanet Data System, aka the Extended Extrasolar Planets Encyclopedia, is aiming to facilitate the public access to the exoplanets data. It promotes the use of existing exoplanet data by extending the global database, and we are going to store all the data generated by exo missions, starting with the unique. And commercial mission partner provides expertise to fundraise for support, educational and outreach activities. Next, the Pink Planets is Science and Technology Committee, STC. It organizes the conference, it holds meeting and workshop, and identify and overlap gaps in existing exoplanetary missions. The third Blue Planet is Program Executive Committee. It is where EXO is managing the unique project and the future project to come. Represented by the Gray Planet is Finance Management Committee, and Purple Planet is Policy Guidance Committee. I will talk about finance management and policy and law guidance later in the... So, next slide, please. Now I would like to take this opportunity to thank our generous sponsors, NASA, Lockheed Martin, and ISU. Without your help and contribution, we couldn't have done the activities we are doing, outreach, education, and research. Not only you are an honorable member of EXO, you have shown your commitment making exoplanetary science approachable to everyone. I would also like to introduce the two types of membership we have for EXO. We have national members, which are space agencies or governmental or intergovernmental entities. They are like space agencies, like NASA. And we also have individual members that are any individual or any entity which has interest in exoplanet research. They are NGOs, private sectors like Lockheed Martin, or academic institute like ISU, and of course, any individuals. Next, please. I'd like to introduce EXO's activities made possible by those sponsorships. EXO helps schools and educators worldwide by providing resources, lesson plans. Sorry. Did I lose? No. Okay. Lesson plans, access to experts, and ideas for trips and activities, as shown in the first photo. The second photo shows you the last year's our annual conference. And the third photo shows you how we helped universities to design and build their own satellite for the unique mission. Next slide, please. Now, guys, this is important. Because we are going to talk about money, and it's always important. Well, to keep these activities going, we must get enough funding, and it's always hard. The pie chart shows here shows how the last year's EXO's income and expense. The graph shows our past record and prediction for next 2 years. As you can see, we are growing strong and steadily. So, for funding, we have three main resources: donations and sponsorships, membership fees, and conference fees. EXO receives donations and sponsorships from various sources, including the public or companies seeking advertising. I'm sorry I cannot introduce all the sponsors today, but I want to stress that we are always grateful. Membership fees are from both national members and individual members. And conference fees for attending the conference are also key source of income, so I encourage you to come to the conference this year. For expense, as organization, we make the payment to maintain the EXO database, to hold plenary and conference. And we also require funds for outreach and education efforts, such as generating educational tools. Also, we need resources to develop mission concept, select missions, and develop mission requirements, as we did for UNIC. Lastly, I would like to mention about the legal matters regarding to EXO. We aim a voluntary non-binding collaboration. So our terms of reference is non-binding. Anyone who is interested in becoming a member shall retain their decision-making power, but follows EXO's decisions voluntarily. However, because EXO is an international organization, we must follow the international laws and applicable national laws. And we ask the members and mission participants to do the same. So the example of international laws we are following are the UN treaties, such as Outer Space Treaties, Liability Convention, and Registration Agreement. And we cannot forget the ITU regulations as well for the satellites and frequencies. We also are very careful about national domestic laws regarding to export controls. And let me finish with our intellectual property policy. Since EXO believes that all exoplanetary findings should be available, discoverable, and usable to everyone, we have very, very open policy. We encourage to motivate space industries, especially those yet spacefaring nations, by making our inventor-own IP policy and almost always guarantee non-exclusive IP rights to everyone who wishes for. Now, let me pass the microphone to Alana for our outreach event. Thank you.
Thank you, Saho. My name is Alana, and I'm the head of PR at EXO. And today I'm going to be talking to you about the education and outreach that we do. So before I get into that, let's take a little bit of a demographic survey of the participants this year in 2020. So how many of you are scientists? Raise your hand. How many are engineers? Oh, so much more enthusiastic than the scientists. How many are in policy and law? That was good. How many are in management and business? And last but not least, humanities. Excellent. So one of the greatest things about EXO is every single one of you, no matter what background you have, can get involved in exoplanet research. And I'm going to talk to you about how you can do that. So if we first look at amateur astronomers, these are the ways that you can get involved. First, you can have access to online resources, and this is in the format of both research materials, and you'll gain access to our database, which I'll explain in just a moment. And the way that you can get access to this database is by taking part in amateur telescope research. So EXO is lucky enough to have industry partners that are willing to give discounts to our members on charge-coupled devices, which you can attach to your telescope at home. And along with a telescope, a CCD, and a computer, you can do photometric data, or you can look at photometric data, which will show you the light curves that Amir was talking about before, and can possibly indicate a transiting planet. Now, once you get this information, you will upload it to, you will process it with the software that we will provide you. Then it will be uploaded to our database, and we can correlate this with other amateur astronomers' research that they've submitted to the database, as well as experts, and possibly confirm that you have confirmed a transiting exoplanet. We also have an annual conference that you are welcome to come to, as well as quarterly publications, which will allow people who are possibly not experts in this field to contribute by getting their research published. Moving on to kids. So here we have some beautiful drawings from children around the world. JF is 10 years old and he loves unique. Matt, holy shnikes, is an alien. Wears his spacesuit. Richard, keep an eye on Richard for a second. He wants to find alien friends. Funny enough, Alana wants to be Sarah Seeger, and she's 4 years old, which is quite impressive. Chris likes pancakes and aliens. And Richard again someday wants to find exoplanets. Okay, back to JF. So first off, we utilize the online video platform YouTube. And some of you may have heard of some other very popular educational videos that have been done through something like Khan Academy or Minute Physics, which have been very, very popular and very helpful to children around the world in understanding complex scientific or engineering topics. So we have created an EXO YouTube account where we've done short, fun videos for students and kids to understand some complex topics and some simple topics. Easy things like what is an exoplanet. Additionally, we've been working with Lego. We're in production right now to create a Lego model that children will be able to buy and build at home, which is very exciting and beautiful in the corner. And next. So for educators, we have developed a series of online downloadable PDF documents that outline a series of workshops or lessons that you can do in the classroom. As well, we are lucky to have a very international membership database, and we are able to hook up teachers with speakers who may be in the area or may be traveling in their area. And these are researchers, they can be scientists or engineers who work for big corporations or national agencies, and hopefully have them come into their schools and talk to the students. As well, we can have students in contact with nearby infrastructures such as universities or observatories that are involved in EXO, and hopefully set them up with field trips for the students. So here we're lucky enough to have a video from one of our teachers in China who went on a field trip recently with the class, and she is going to tell us what their experience was like.
大家好，我的名字叫丁杰，我是中国北京的一名教师。这次 EXO 为我们学校组织了去新北京天文馆的实地考察，他们有一个系外行星的新节目，孩子们非常喜欢。通过参观，同学们学习了许多天文知识，认识了不同类型的行星。在参观快结束的时候，天文馆的导游问班上有谁愿意帮助寻找新的系外行星，所有人都举起了手，当然也包括我。这真是个令人难忘的经历。
And last but not least, we're going to talk right now about how universities can get involved, because many of you are probably students. So there are two ways that you can get involved. The first is through actually having your university be a part of one of the unique missions. And the second is applying to be a ground-based station through existing infrastructure. So for the first, EXO has an open request proposal to which you can apply for a mission request proposal. And we've created, as you saw before, and Dan explained, we have a unique satellite which we've built as a prototype of sorts, and we've already launched one. And that can be used by your university as the satellite that you build, or you are open to building a different type of satellite as long as it meets the mission requirements that EXO has set out. And secondly, you can apply as a ground-based station through existing infrastructure. So if your school is lucky enough to have infrastructure like a large telescope, or if they're affiliated with one, you can apply to do research missions through our program, where we will hook you up with the database as well as the schedule for when our unique missions are going to be looking at specific stars. And then you will be told to turn your telescope that way as well. and hopefully we can coordinate with both the unique missions that are space-based and ground-based. So funny enough, Richard grew up and is now a researcher, and he is involved in one of the unique missions. He's also the computer guy, which is kind of fun. So we're going to listen to what Richard is involved in right now with the unique mission.
Oh, hey, I didn't see you there. G'day, I'm Richard, an engineering grad student working on Unique Sydney, one of the next unique mission satellites to be launched next year. The Unique project asked my uni to join because of our expertise in the field of infrared optics. We help to design the next generation of unique sensors, and in return, we're getting cutting-edge knowledge of attitude control and orbital mechanics. Here you can see one of the possible Unique Sydney Sun-synchronous low Earth orbits. This orbit promises that our satellite will always face away from the Sun, and that the sensor is always available to observe the transit events we want. By joining Unique, my university has been able to share our technological experience and expand to new areas of research. Thanks, Unique.
So, as I've just said, and as you can see here, there are lots of ways to get involved in exoplanet research, even if you are not an expert in the field already. We really hope that you will all be involved, and you can do so by joining us and clicking here. And here you can sign up, and we will be in contact with you and discuss what type of membership you would like, and we hope that we get a whole bunch of new requests in the next little while. Thank you.
Okay. Yep. Thank you, Lana. Okay, so thank you for your attention, everyone. I just have a few closing remarks. Firstly, this is actually a live website. If you go to exoplanets.isunet.edu, you can visit this and find out more information. There are quite a few hidden things in there for you to find. One thing I also wanted to say is that, as you've seen by today's panel, the things which can come out of ISU and SSP are particularly amazing. So I encourage you all to really go out there when this finishes, have a go, and really make things happen. It's what you're here for. Okay, so next I'd like to actually ask the entire TP Exoplanets to stand up, and if everyone could give them a round of applause for their fantastic work over the last 9 weeks. And then we have 3 of our supporting experts. I would like to join us on the stage. And then we have a few Twitter questions before we open the questioning up to the floor. So can I have our questions which have come in throughout? Great, thank you very much. Okay, so our first question is, what is the data policy for the unique mission, including intellectual property? So, Saho, would you be able to answer this? Is that right?
Well, thank you for the interesting and useful question. Well, I would like to start with the basics. The unique satellite data image belongs to each satellite owner. And if you utilize the unique satellite and take any other data not associated with unique mission, that is the participant owned as well. But we ask the unique participant to share the unique data between the participant and to us. And we are going to put that to EXO database, as I said in the presentation. And after the data is put into the database, we have very open policy. So if we have any unique related IP, we grant non-exclusive right to reproduce the IP. That means anyone can use the unique data image without paying royalties or license fees. Then we have an inventor-owned IP policy. Title and ownership of all IP resides to the party in which invented or created the IP. So that means if a scientist creates a work that's covered by copyright law of that scientist's country, he or she can own the copyright, and EXO will not make any claim against it. However, I would like to mention one important thing, that is data exclusivity limit period. We ask 6 months of data exclusivity. It's chosen as the reward to the unique participant, so they can have prioritized access to the data, as well as the data is being ensured to proper calibration before releasing to the public. I hope this answers to your question. Thank you.
Great, thank you very much. So our next question will go to one of our specialists here. This is from Giacinto in Italy. He's asking, I'm an amateur astronomer, and why should I join you? So Daniel, are you?
So that's a great question, and bringing in amateur astronomers is a very important part of our organization. There are a lot of things that we do to support you, and I think they're kind of fall into 3 categories. The first is to help you bring in the public and engage them with exoplanets. So we provide you with educational and outreach material to share with your community, to bring them into the exoplanet community. We also support you in contributing to the field. So as was mentioned earlier, discounts on equipment to help you find transits and information about where to point your telescope and what to do with the data afterwards. And finally, we want to help you grow professionally. So we would give you access to come to our meetings and meet with other interested amateurs or professionals.
Thank you very much. And our last question before I open it up to the floor, this one will go back to our panel, to Daniel. So why should I use your database? What makes it better than some of the others out there?
Okay, so our database is the most complete database out there. When we set up with EXO, we looked at what databases were out there. We saw there were very good databases. We wanted to utilize what is already in existence. We actually coupled different existing databases, and we added any data that we could add into that. So we added more planets, more sources of data into it, as well as more fields looking forward. So if we look at the databases that we had in 2014, hardly any of them dealt with the atmospheres, for example. So we added atmospheres into the database. Only a very specific one dealt with transit events and had people being able to see when is the next transit event of an exoplanet. So we added that to the bigger database. And we also made better interfaces, first of all, to other databases. So we actually have data flowing from our partners and going out to everyone according to the policy that Saho presented. And we also have better user interfaces. So we have big tables that scientists can use, and we have very cool sky maps that you can just click on a different area and find whatever exoplanets in that neighborhood.
Great, thank you very much. Okay, so I will now open up any questions to the floor. Thank you for your attention, everyone.
I thought it was a terrific presentation. Now that we're in 2020, I was wondering if you might take us back to 2014 and go back and tell us what you think we could have done differently in 2014. All the leaders of the industry back then, and we've made a mess of it apparently for you all. So tell us what you would go back in history and time and do better for the world in 2014.
Daniel?
So one of the things that we did was gather information from a bunch of different experts, and we felt that one of the gaps is that there was insufficient communication between the different big organizations. I think each has their own roadmap, each university has their own idea about what's going on. There's some look at what other organizations do, but I don't think there's a true understanding of it, and that's where we think EXO could be of help. Helping to the larger groups to communicate and maybe have a unified roadmap coming, forward, helping them to communicate with each other so that we don't duplicate effort and so that we can share information that's already learned across I think that's one of the key areas.
So I really liked your explanations and videos about the different methods for exoplanet detection. And I noticed that the EXO mission is really focused on transit type detections, of which we already have a lot, and which this will continue to grow. So the one I think many people would be interested in, however, in addition to the transit method, is the direct imaging method, where you can not only image the planet, see a pale blue dot, oceans and clouds, but also do spectroscopy and look for biomarkers, biosignatures. So in your research, have you looked at what type technologies would be necessary for those types of direct imaging?
Me?
Sure. So very relevant question. And actually, the James Webb Space Telescope I mentioned is doing exactly that. It has coronagraphs, which should try and block the sun and actually do direct imaging and spectroscopy. And we also have a couple other missions that are trying to do this. But none of them are small and low cost, and they cannot look at all these thousands of transit events happening again and again. So they can find some very few planets and characterize them, but it is still an $8 billion telescope trying to do all of that. So we will have in the next couple of years, or looking in 2020, we already have now a couple spacecraft that are doing this spectroscopy, but not enough, and they are way too expensive, and we can get a lot of these measurements in a very low-cost way, which is what we are trying to do. But both direct imaging and spectroscopy are things that are happening right now.
So I was interested in the comment that you'll be able, now sitting again in 2020, that these amateur astronomers are able to get equipment at a reduced price, whatever, and that they can do transit work. Recalling some work that I was involved with a spacecraft called Kepler way back when, I realized how challenging transits were and how it had to be out in space and had to be very precise. Has there been some kind of breakthrough between 2014 and 2020 to give you confidence now that amateurs with some kinds of CCDs that are then available in 2020 would be able to do transits?
Actually, now in 2014, back to 2014, there are actually people doing it from the ground by amateurs. There is a database called AXA, Amateur Exoplanet Archive. It's a very short list, about 30 or 40 exoplanets, but there are exoplanets that can be seen, not the very smallest telescopes, but telescope owned by private individuals.
And not just billionaire individuals.
I haven't checked their...
I may have missed this, but you've got this database together. Do you have these instruments looking at the same object, and then you do some type of statistical analysis as well in order to make sure that while a single telescope might not have the technical ability to do the science, you might have 10 of them that statistically you can establish a level of confidence?
So yeah, according to our plan is, if we have one single very important event, we'll have all of our tools looking at it in space and on the ground. If we have multiple events of interest, then we'll have to reconsider and see how we manage that. But basically, yeah, if there's a very important thing and the science team behind it, unique, finds that something that very important that has to happen, that is going to happen, we're going to send everyone to look at it. That's a good thing about, we know when these things are happening. So we can look ahead very far, and we can plan these things.
So the multiplicity of the instruments is not because of synthetic aperture or anything like that. It's actually because of the fact that you're going to put it in a database, you're going to get multiple observations, you're going to analyze the data later, right?
Yeah,
so it's more than a database, it's really analysis tools as well.
definitely the database, even databases in 2014 are great tools for analysis, looking at the big exoplanet population and processing different data about the same object from different sources. So it's something happening in 2014 and could definitely grow with the more sensors we have.
Okay, thank you.
Yeah, if I understand correctly, your operating plan is to have an expected life of 3.5 years, and you're in sun-synchronous orbit with what amount to nanosatellites. What's your deorbiting plan for that? That's already getting to be an orbit of concern?
Can I introduce Thomas?
Well, regarding the orbiting system, we consider some options like using thrusters, using a sail to reduce the altitude. But today on this small satellite, microsat, CubeSat, there is no commercial equipment that allow to do this disposal operation. So that would require specific studies for this specific size of satellite. But thruster or sail are valuable options.
Thank you very much. Super. Well done. Congratulations to all teams. That was a great day, and I think everybody really enjoyed it, and I hope you did as well, because we certainly did, listening to you and watching you. Before we close, I'd like to bring 4 people up on the stage, if they're all in the room. Thomas, Adam, Erica, and Matthew, if he's here. As you know, you've heard this morning or today from your chairs, and these are the people that led you from the beginning, so please give them a huge round of applause. Thank you so much. That was totally appropriate. So thank you. Now we get into we break up. I'm going to lead the experts and the panel members. The members that were grading the presentations today, and we're going to have a chat with your chairs. Just to give you the feedback to the chairs. It shouldn't take that long. I don't think you'll hear anything that's other than praise, but we want to give you the feedback, an honest feedback on what we heard and what we like to provide to you. That feedback will then be relayed back to you in your TP rooms from your chairs, and then. But in the meantime, the president of the ISU, Walter Peters, would like to spend a little time with you alone. This is just the participants. Oh, and I forgot to mention one more thing, very important thing. Throughout this whole session, we have been blessed with an amazing audio-visual team that has kept the whole process going, that has managed all of the work that we've done today, that has live broadcast a lot of the excellent presentations we've had. So could I please ask you to recognize Marina, Mark, And Julian is at the back somewhere, so well done. Thank you, guys. It's been flawless, and I know that sometimes the circumstances have not been pristine, but you've managed to pull it off every time. So thank you so much. So we're going to disappear. I'd like the staff and the TAs also just to leave, so that the president can be alone with you to get some feedback from you. And as Eric mentioned yesterday, this feedback is extremely important for the ISU, and the comments